Ixb is equal to bh cubed over 3. But from Tuesday's lecture, we have learned that Ix prime is equal to bh cubed over 12. So are these two related? Because here we have Ixb is equal to bh cubed over 3. And on Tuesday, we talked about Ix prime is equal to bh cubed over 12, which is on the previous page here, right? This one. Remember, this x prime is means centroidal axis. Now, so are these two related? Remember, this Ix prime means this axis, and the distance is y prime. The distance of this area to axis x prime is y prime. Please make this mark here. So are these two related? So let's take a look. Let's take a look whether this one bh cubed over 3 and this bh cubed over 12 are related. So we look at this one. Oh, sorry. We look at this equation. How should I mark this? We look at this one. Now, and we look at these three things, these four things. Now, because x prime and xb are parallel, so can we write a relationship between yb and y prime? Yb and y prime. Let's look at here. So if yb is equal to 0, y prime, because x prime y prime is related to centroid. So if yb is equal to 0, y prime is equal to minus h over 2, right? Because x prime y prime is here. X prime y prime is here. So at this level, yb is equal to 0 and y prime is equal to minus h over 2. And in the middle, h is yb is equal to half of h. So y prime is equal to 0 because we have the coordinates here, right? And for the upper edge, for the upper end, we have yb is equal to h and then y prime is equal to h over 2. So we can write a relationship between the two. Yb is equal to y prime plus half of h. Is that okay? Does it sound logical? So for any coordinates that for any point here, that if we have yb, that of course we can write y prime, and yb is equal to y prime plus h over 2. The second thing, let's look at dA. dA from here, it is equal to b times dyb. How about if we write it in y prime? So here we have y prime. So what's the thickness of this stripe? Of course, we write here is dyb, and here we have dy prime. Because we write everything here in y prime, okay? So this one is dy prime. So we have these two things. Therefore, we use this relationship to replace these three, and use the second relationship to replace dyb. Right? How should I? Wait a minute. Oops. Should I use two colors here? Here we have we use the blue equation to replace these three, and we use the yellow equation to replace this. So what do we have? Ixb is, let's write down the integral first. Huh? So yb squared would become y prime plus half of h squared. It's okay. So for this yb squared, and then we will get y prime plus h2 bracket squared, because we have this, right? Remember, we have this one and this one. Now, and then b times dyb would be equal to b times dy prime. So we have, and then b times b dy prime. And for the upper and lower limit, because here we have from 0 to h. So if we write it in y prime, we would have minus half of h2 plus half of h. Does it look logical? We begin from here. Okay, we begin from here. We know this one. So we just put the equation below to the term I put my arrow. So it becomes this one. Right? And for dyb, and for this dyb, that we become b dy prime, because we have the same area. And because in yb we integrate from 0 to h, but now because we write it in y prime, we have minus half of h2 plus half of h. Suppose, so let's have this. If we have this thing, we can write, you can say explode or expand this one. Expand is 扩张 or 展开。So we expand this into three terms. So we have these three, right? We can have these three, and oh, sorry, that I should have a prime here. So we have expansion. We have expansion on this bracket. We can get these three terms. if we have these three terms, of course it looks scary, but it is not that difficult. So let's look at them. The first term is, what's the first term? We have this is dA and this y prime squared dA, which is, this is equal to Ix prime. The first term is equal to Ix prime. And we look at the third term. For the third term, we have half of x squared times dA times integration of dA. Then this is equal to half of x squared a. Then how about this one? How about the thing in the middle? Please write it down, and I will discuss this. For the second term, it is equal to, the second term is equal to this one, huh? Right? Because we can move h outside, and b dy prime is equal to dA. So we get this one. So how can we move on from here? So from chapter 5, can we simplify this using what we learned in chapter 5? The answer is yes, this one is equal to h times, should I use another color? H times y bar times a prime. I'll give you time to write this down.有没有看起来觉得怪怪的东西，或者是完全就是一眼就觉得，为什么这样？沙发是需要时间消化的，但是有没有一些现在就觉得怪怪的？记得说好。 Now, so from here, this is the centroid of y in the y prime. Of course, because it is on centroid, so it is equal to 0. So this one is equal to 0. Okay, so therefore IXB is equal to IX prime plus half of H bracket squared times A, which is parallel access theorem.